Welcome back, everybody. This is Miss Maneely, and I am here to help you get through the second part of your Algebra 2 midterm review, and this is now the calculator section. So we'll go ahead and begin with number 1 in the calculator section, which says, for 30 minutes you exercise doing interval training, which is a combination of walking and running. At the end of your workout, your smartphone exercise app reads 2.5 miles. You know you walk 0.05 miles per minute and you run 0.1 miles per minute. Write a system of equations to represent the situation. Be sure to define the variables you use. And ultimately, we're trying to answer the questions, how long were you walking and how long were you running? So we're trying to answer questions that deal with time. And the questions are actually going to help us define the variables. You'll notice as I start writing that my handwriting is really sloppy, and that's because I'm trying to do these tutorials at home using a tablet, which is a lot harder to write on than my smartboard. So I apologize in advance if my handwriting is really sloppy. Also, my dog is in the background chewing on a bone, and so she's being really loud. So again, I apologize for that too. I hope it's not too distracting. So the question again is asking how long were you running and how long were you walking? So the first thing we need to do is identify our variables. So I'm just going to go ahead and let X represent the time walking. Sorry about my handwriting. And Y is going to represent the time that we were running. Now, when setting up a system of equations, these are both going to be linear equations. It's important to note whether or not you're going to be writing the equations in slope-intercept form or standard form. And generally, with slope-intercept form, remember, let me just jot down an equation down here. We have Y equals mx plus b, where m is your slope or some sort of a rate, and b is an initial value. And X and Y generally represent two different quantities. So like the money you make per hour at a base pay, and Y would represent the total salary. So the other type would be if you have standard form, which is AX plus BY equals C. And when we write an equation in standard form, X and Y tend to be similar quantities. And in this case, if you look, the time walking and the time running are very similar quantities. Both involve time. So it turns out that both equations that we're going to be writing, sorry, all my other icons keep coming up, the type of equation that we're going to be using is going to be standard form. And so with standard form, we're also looking for totals. So for example, I know that I was doing 30 minutes of exercise and that the total distance was 2.5 miles. So I have my total time, and I have the total distance. And I think that writing this out helps kind of put the information in order for you. So for example, total time. Well, if you look at your variables, we've got the time walking and the time running. And I know that the total time that I was exercising was 30 minutes. Oops, my TV just popped on. Okay, so I know that, again, that I was exercising for a total of 30 minutes, and that X minutes I spent walking, and Y minutes I spent running. So there's one equation right there. The other would be the total distance. And so I know that I went a total of 2.5 miles. So now let's relate all the distance information. So for example, I know that I walk 0.05 miles per minute, and that's walking. So if I take 0.05 and multiply that times X, that's going to be the total distance that I spent walking. I'm sorry, this is just not writing very well. So I want 0.05x and then 0.1y. And that'll give me the total amount or the total distance that I traveled while I was running for y minutes. Okay, so now that I have my two equations, there's my system. I want to solve it. And there are a couple different ways that you can solve it. In this case, I think that using linear combinations is probably going to be easiest because I can just cancel one of my variables. So I'm going to go ahead and work with canceling my y variable. If I multiply my first equation times negative 0.1, then I can just distribute that all the way through. And so if I multiply negative 0.1 times x, I'm going to have negative 0.1x, negative 0.1y, And then if I go to my calculator and do negative 0.1 times 2.5, I'm sorry, times 30, we get negative 3. And so now I'm just going to combine those two equations. So if I have 0.05 minus 0.1, we have negative 0.05x. My y's are going to cancel, and then 2.5 minus 3 leaves me with negative 0.5. And now all I need to do is divide by negative 0.05. And so x is going to equal, let's go ahead over here, so we have negative 0.5 divided by negative 0.05 should be 10. So that means I spent 10 minutes walking. And it's pretty easy. If I know that I spent 30 minutes exercising altogether, I know that I must have spent 20 minutes running. Okay. Problem number 2 deals with sequences in series. You're given the formula sheet, which I've already attached to this page. The formula, I didn't actually include. This is for an arithmetic sequence, and this is for a geometric. So these are the rules for sums of series. And in number 2, it says, what's the rule for finding the sum of a finite arithmetic sequence? So finite is right here. Arithmetic is right here. This is the rule, where n represents the number of terms in the sequence. A sub 1 is the first term. A sub n is the last, and we divide by 2. We're essentially finding the average of the first and the last term, and then multiplying by the number of terms in the sequence. I'm not going to rewrite it since I've got it down here. So in letter B, it says to find the sum of the first 15 terms of this arithmetic sequence. So it goes 2, 6, 10, 14, 18, and so forth. So what I know the value of n is going to be 15 terms. I know a sub 1, right? These are all the terms I need. I need n, I need a sub 1. A sub 1 in this case, the first term is 2. And then a sub n would be the 15th term. So I need to figure out what the 15th term is. In order to do that, I've got to recognize it's an arithmetic sequence. So I'm actually going to use, I have my formula sheet, I'm actually going to need to use my formula for an arithmetic, the explicit formula for an arithmetic sequence, which basically takes my first term plus the common difference times n minus 1, and that'll give me the 15th term. So I know, for example, that, so let me see if I can I show both of them? Oh well. So I know I need my first term, which is 2. The common difference, so let's see, what's the difference between each of these terms? I'm going 6 minus 2 is 4, 10 minus 6 is 4. So my common difference in this sequence is 4. So I'm going to be adding 4, and then I want to do n minus 1. Well, again, n in this case is 15 minus 1. So I can do this on my calculator. So we want to do 2 plus 4 times the quantity 15 minus 1. And we get that the 15th term is 58. Now again, that's just the 15th term. We want to find the sum of those terms. So the sum of the first 15 terms is going to be n, which is 15, times a sub 1, which we said is 2, plus a sub 15, which we said is 58, and we're going to divide that whole thing by 2. And again, I can just do this on my calculator. So 15 times the quantity, 2 plus 58, divided by 2. And that gives me 450. And then in letter C, we're asked to do the same thing, except we have a different sequence. So this time we're finding the sum of the first 18 terms, using a different color. So I know that, whoops, that n is going to be 18 now. I know that my first term, a sub 1, is negative 7, but I need to figure out the 18th term. And so I'm going to start with my first term, negative 7. Now I've got to figure out my common difference. Negative 5 minus negative 7. -5 minus a -7 is the same thing as -5 plus 7, which is 2. Another way of looking at it is each of these numbers is going up by 2. So my common difference is 2. So I'm going to do plus 2 and then times n minus 1. Well, in this case, 18 is n. And so I can figure out my 18th term simply by plugging in the formula. And we get 27. So if I want to find the sum, I'm going to take my n value, which is 18, times the first term, plus the 18th term, and all of that is going to be over 2. And if I plug that into my calculator, 18 times -7 plus 27, oops, divided by 2 leaves us with 180. Okay. All right, next problem. Number 3. It says that Joel gets a tax refund. Oops. Okay, Okay, so for the next problem, we're told that Joel gets a tax refund of $2,500 every year, and he deposits it in a separate account from his other money. He reviewed his spending habits from the previous year and realized that he spent an average of $125 of his tax return each week. How many weeks did it take for Joel to spend last year's tax refund? So if I think about what he started with, I know he started with $2,500, and I know he spent $125 each week. So if I let X represent the number of weeks, and if I want to figure out how long it took him to spend everything, then I'm going to set this equal to 0, because that would mean that he has nothing left. So to solve this equation, I can do a couple different things. Essentially, I want to get the variable on one side, the number on the other. This is just a two-step equation. It's a linear equation. So if I add 125x to both sides, I'd have that 2,500 is equal to 125x, and then we can divide both sides by 125. Sorry, my handwriting is difficult on this thing. So on my calculator, 2,500 divided by 125 took 20 weeks. So in 20 weeks, that's about 5 months. So in about 20 weeks, he spent the whole refund. So in part B, it says, Joel wants his tax refund to last longer this year, so he creates a budget for himself. This year, he will withdraw 5% of his refund balance each week. How many weeks will it take for his balance to fall below $1,000 with this strategy? So that means if we're looking at withdrawing 5% each week, then now we're looking at an exponential decay function. And if you remember, an exponential decay function, we have what we initially start with, and then 1 minus the rate at which we're taking it out, raised to the x or the t or whatever time variable you want to use. So in this case, again, we started with the 2,500. And since we're deducting 5%, it's going to be 1 minus, remember, change your percent to a decimal, 0.05 to the x. Or another way of writing that would be 2,500 times 0.95 to the x. And I essentially want to know how long it takes to get to $1,000. So we could try to do this with logs or just use our calculator. And I'm just going to clear out the equations that are in here. Notice that my plot is turned on, so I'm going to press enter to turn that off. I'm actually going to go ahead and just use my graph to solve this equation. So if I use 2,500 times 0.95 to the x, the second equation is just 1,000. So the next step is to find an appropriate window, and I know this is sometimes what people struggle with. If you start with the zoom 6, that's your standard window. You really don't see anything. And if you think about it, x represents time, and y represents the money in the account. Well, I started off with 2,500, so if we go to my window, I definitely want my y max to show that I had $2,500 in the account. And that really is as much as I need in terms of my maximum, since I know these values are decreasing. The next thing I want to think about is the value of x. Well, I know when I was just deducting $125 each week, I was able to last 20 weeks. My x values go from -10 to +10. I don't really need any of these negative values, so I'm going to go ahead and make my x min 0, and my x max, I'm just going to go ahead, just in case it takes a little bit longer than it did with the other equation, I'm going to go ahead and just say my x max is 25. And now I'm going to hit graph again. So now you can see the balance in the account is starting to decrease. And that horizontal line represents when the balance is 1,000. So if I want to figure out the value of x, I'm simply going to figure out this point of intersection. So second trace gives me the menu that I can use to find the intersection. And since there's only one intersection point, you can simply hit enter 3 times, and it'll calculate that for you. And so x equals 17.864 weeks. So that's pretty good. With the other method, he, is broke in 20 weeks. With this method, at 18 weeks, he still has like $1,000 left. So that's pretty decent. And number 4, it says, Stacy is a professional photographer. Each photo shoot generates 50 photos, which she stores on a flash drive. A flash drive can store up to 10,000 photos. Write a recursive formula to model the total number of photos that Stacy takes. Okay, I just realized that part B of that question wasn't included, so I went ahead and included it. So it says to write a recursive formula to model the total number of photos that Stacy takes. So remember with the recursive formula, this is going to be arithmetic since we're just adding 50 every single time. And so if I go to my formula sheet, the recursive formula for an arithmetic sequence looks like this, where a sub 1 is the first term in our sequence, and then we determine the next term by adding that constant value to the term before it. So this is pretty straightforward. It's just going to be, it's going to be a sub n plus 1, so that's the next term in the sequence is basically going to be 50 plus whatever the term before that was, which is just a sub n. It asks what the domain is, and then is it discrete or continuous? Anytime we're dealing with sequences and series, our domain is going to be the set of all positive integers. It's going to be positive integers. And because they're integers, it is a discrete domain. Discrete is something that we can count. Continuous is something that has to be measured. So, for example, if you're thinking about real numbers, there are an infinite number of values that are between 0 and 1. So that's something that's continuous. I can't list them all. Discrete, though, we can actually count them, and the integers are going to be discrete because we'd start with 1 and then 2 and 3 and 4. I can count them. Other quantities that would be discrete would be counting the number of people in a room or the number of chairs in an auditorium, where continuous variable would be something like measuring how much gasoline I'm putting in my car or how much water is draining out of a bathtub. I can't count the water. I can't count the gasoline. It's something that I'd have to measure. Okay, in the next problem, it says the population P in millions of a town in California is given by the equation, where T equals 0 represents the year 1980 and K is a constant. In the year 2000, the population was 1.65 million. If you guys remember, when we learned about exponential functions, that coefficient happens to be the initial value. So in 1980, the population in this town was 4.35 million. And then in the year 2000, the population was only 1.65 million. That tells me that the population is decreasing. And if it's decreasing, then ultimately, my exponent must be negative. And that's going to be important for us as we go to solve this equation because we're going to rely on our calculator and setting up an appropriate window to do that. So essentially what I'm trying to do is determine the value of K. So if I think about my equation, I've got P is equal to 4.35 e to the kt. So I have 3 unknowns in that case. But if I use this piece of information where I know in the year 2000 I had 1.65 million, then I can go ahead and plug those values in for P and for T. So the population, P, would be 1.65, and that would equal 4.35 E raised to the K, which I don't know, times T. Well, I have to figure out the corresponding time, or T value, for the year 2000. Well, I know that T equals 0 corresponds to 1980, and 2000 is 20 years later. So that's going to be the value of T that I'm going to plug into my equation. And so now I can just go ahead and enter each side of the equation into a different equation on my calculator. So let me clear out what's in there. And so if I enter 1.65, and the other equation is 4.35, and then I'm going to use my E. And notice that you need to have parentheses around your exponent. I'm going to go ahead and type this in. That was 20x. And I'm going to go back to using a standard window. So I'm going to go back to using Zoom 6. So 1.65 is there. And notice you can barely see my function. And if you think about it, that's because these values are actually pretty small in terms of what I'm using for my population. I really don't need my population to go from -10 to +10 because my population looks like it's between 0 and 5. So I'm going to go ahead and change my window a little bit. I am going to keep some negative values, so I'm going to keep it, I'm going to go from like maybe -2 to, I'm sorry, I'm talking about x. Let me go back down to y. In terms of my population, I don't think I'm not going to have a negative population. I'm not going to have any negative quantities in terms of my population. And the most my population is going to be is 4.35, since I can see that it's decreasing. So I'm just going to go ahead and make my y max 5. So the other thing that I want to pay attention to is the fact that K must represent the rate at which my population is changing. That means that K is corresponding to the R that we're used to seeing. So it's got to be a decimal value, and it's got to be negative, since I can see that my population is decreasing. So when I think about my values for x, x in this case represents my rate. It represents this K or this R, however you want to think about it. So I know it's got to be a decimal, and I know it's got to be negative. So really, if I just go from, say, -2, let's go to +2 and see if that is a good enough window for us to see what's going on. So there again is the population that I'm looking for. And now I can see where the two graphs intersect. So if I hit second trace, intersect, I can see that the K value in this case is -0.0485. And let's see, I'm just going to go ahead and round that to 0.48. So about 4.8% decrease in the population. So then it asks us to predict the population in the year 2010. So in order to do this, I'm going to go back to my original formula, and I'm just going to replace the K with this value that I found. So P is equal to 4.35 E to the -0.048 T. And what I'm asked to do is predict the population in the year 2010. So again, T equals 0 corresponds to 1980. 2010 is going to correspond to T equals 30. And this, I'm actually going to just use my, my calculator to help me with this. So for example, if I go to second trace, I might be able to do this on here, to find, actually I have to go back and change, I'm sorry, I do have to go back and plug the new equation in. Or actually, you know what, I can just do this on my home screen. There are a couple ways you can do it. But let's just go ahead and do this on the home screen. 4.35 times E raised to the -0.048. Now I've rounded, so my answer is going to be a little bit off. But as long as you show your work, I think you'll be okay. So you want to show all your work, and we'll find that the population in the year 2010 would be 1.031. million. Make sure you use appropriate units here. And then it asks, what was the average annual rate of change in the population of the town from 1980 to 2010? So in 1980, we knew that the population was 4.35 million. And then in 2010, we just figured out that the population was 1.031 million. So when it's asking about rate of change, just go back to what you did in Algebra 1 and find the slope. So essentially, I'm going to find, if I call this x and I call this y, I'm looking for the change in y over the change in x. So if I look to see how y is changing, just make sure you're subtracting in the same direction. So if I do 4.35 minus 1.031, I get 3.319, and I want to divide that by 1980 minus 2010. Now notice I'm going to end up with a negative number here, and that makes sense because I know that my population is decreasing, so my slope should be negative. And then if I just divide 3.319 divided by negative 30, I find that the population is decreasing by 0.1106 million people per year. There you go. So that's how you do that problem. And number 6, it says Sam and his friends love skeet shooting, where they throw clay plates into the air and attempt to break the plates by shooting them with plastic BBs. So suppose f of x represents the height of a clay plate, and g of x represents the path of a BB plastic pellet. It says to sketch the graphs of the functions below and determine the solutions to the equation. So I'm going to go ahead and just graph these on the calculator since it's the calculator section. We've got negative 2 times the quantity x minus 6, the quantity squared, and then we've got plus 10. And then the other equation is just x plus 1. And again, I always start on the standard window, zoom 6. And then if I have to adjust it, I will. And actually, that works pretty well. I mean, I really only have to worry about this first quadrant, but whatever. I don't need to change my window. So there's my the clay plate, and there is my BB. So there's the BB, and this is the plate. Okay, and so the next thing we want to do is to determine the solutions. Determine the solutions. So I can do this on my calculator, second trace. I'm going to use my intersect option. Just be careful because I have 2 points of intersection. So where it asks for the first curve, I want to make sure that I move my cursor. Where is it? There we go. I want to keep my cursor close to the first point before pressing enter. So one of the points is 4.5 and 5.5. And then I have to go through the whole process again to find the other point. So second trace, intersect, but this time I'm going to move my cursor to the other point, and then I'll press enter 3 times. And the other point of intersection is 7 and 8. And it says to use algebraic methods to confirm the solutions or to confirm the solutions to the system. So here I'm just going to plug the values in for x and y and show you that they actually end up solving the system. So, excuse me, I'm just going to do this on my calculator. Obviously, you're going to want to write this out on your paper, but if I go into my calculator, I'm just going to do this. Oops. I'm just going to show that this is true. So for example, if I type in negative 2 times the quantity x minus 6, so if I use the first ordered pair, I'd use 4.5 minus 6, and I'd square it, and then I do plus 10. And I should get 5.5, and I do. Another way, if I plug the 4.5 in for this x, I know if I add 1, I get 5.5. You'd want to do that for both points to show that it's true. And then it says to write the solutions in the context of the problem. What I'm guessing, because in this problem it doesn't really talk about the values of x and y and what they represent, My guess is that they're going to be the horizontal and vertical distance from the two boys that are playing, or that are throwing these plates and playing with the BBs. So the plate and the BB will intersect when the horizontal distance is 4.5 or 7 feet, and the vertical distance is 5.5 or 8 feet, respectively. Sorry, I know my handwriting is terrible on this thing. And when we say respectfully, it just means that the 4.5 and the 5.5 go together, and the 7 and the 8 go together. And finally, it says, explain what f of x is less than g of x means in the context of this problem. Well, f of x is my plate. Let me trace this with another color. So if f of x is my plate, if I want to know when then f of x is less than g of x, it just means that the plate is below the BB, or the BB is higher in the air than the plate is. All right. And number 7, it says you've been presented with 2 investment opportunities. The return on investing in the stock market follows the model of f of x, and the return on depositing the money into a CD account follows the model g of x. For both models, x represents the time in years. It says, well, when will the 2 plans yield the same return? Okay, so this is easiest just graphed on my calculator. So if I go into y equals, I'm just going to type both of these functions into my calculator. So we've got 1,000 and 1.15 to the x. And then we've got this linear equation where we have 6,000 plus $209.85 times x. Okay. And again, if I start this on a standard window, zoom 6, you can see that I don't really see anything. Nothing's happening. So that's usually an indication that I need to adjust my window settings. So think about what x represents. X represents time in years. So I really don't need to go back in time, so I'm going to set my minimum at 0. And let's say that I'm investing for the long run. So let's say I'm, maybe I'm doing my retirement account. So that money could be invested for up to 50 years or more even. If I think about the equations themselves, y represents the balance in the accounts. I can see that the initial value here is 1,000 and the initial value here is 6,000. I can also see that both functions are increasing. So the maximum for y has to be greater than 6,000. So I'm going to go ahead and just make it, 20,000. I'd rather it be too big than too small, because then at least I can see the graph. And so there's my exponential function. And there's my linear function. It says, when will the 2 plans have the same return? I'm just going to use second calc, intersect, and find that place of intersection. So this one's going to be best solved using the graph. And that point occurs at 15.99999, which is actually 16 years. And the total in the accounts would be a little over $9,357.60. So I want to go ahead and put that in terms of the problem. So in 16 years, both accounts will have $9,357 and about 60 cents. Let me just fix that so it actually looks like a 16. There we go. All right, number 8. So this is an interesting problem, and it took me a while to figure out how to go about solving it in a way that would actually make sense to you guys. So you're given a system of equations. You're given y is equal to x minus h squared plus 2, and then you're given y equals negative x plus 8. The problem is you don't know the value of h, so we've got to figure it out. So in all honesty, I don't even think you need the second equation. I actually set up a different system of equations just using this first equation. And the way I did it, oops, what did I do here? The way I did it, I may have actually made more work for myself, but this is how I solved it. I basically took this equation, and I knew that when x is 2, y must be 6, and when x is 5, y must be 3. So I just used the first equation, and I just plugged in what I knew. So for example, if I let y equal 6, then 6 must equal 2 minus h, in this case, squared plus 2. And so basically what I did is I subtracted 6 from both sides, and I got that 0 is equal to 2 minus h, the quantity squared, minus 4. And then I just kind of left that there for a minute. And then I used the second piece of information. And I said, okay, so let's go ahead and let x be 5 and y be 3. So 3 must equal the quantity 5 minus h squared plus 2. And then I subtracted 3 from both sides. And I found that 0 is equal to 5 minus h, the quantity squared, minus 1. And so since both of these are equal to 0, that must mean that they're equal to themselves. So I basically just set them both equal to y. I just made a system here, and I solved for h, except I called hx on my calculator. So basically I have in parentheses 2 minus h, or in this case I'm going to have to use the x variable, squared minus 4. And then in the other one it is 5 minus h, or in this case I'm going to use the x variable, and that's minus 1. And I'm going to go back to using a standard window because that's always where I start. And I'm looking to see where those two graphs cross. And they cross at 4. So when x is 4 in this case, or when h is 4. And so one of the things that we can just double check is to make sure that that makes sense. So if I rewrite this equation as y equals the quantity x minus 4 squared plus 2, and then the other equation is y equals negative x plus 8, I can either test the 2 points to make sure they work, or I can just go ahead and graph the 2 equations to make sure that they actually intersect where they should. So if I type in, and you don't have to do this, I'm just showing you that it worked. And we've got plus 2. And then we've got the other equation is negative x plus 8, which we didn't even use in solving this system. Okay, so I just want to double check that my ordered pairs work. So I'm going to move my cursor to the first point, which is right there. If I press enter 3 times, I see that they intersect at 2, 6. And if I do second trace intersect again, this time I want to move my cursor to the other point, and I find that they intersect at 5, 3, which is exactly where they're supposed to intersect. So you can actually solve this problem without even using that second piece of information, which is what I would recommend doing because it was a lot easier to do it that way. Okay, 9 and 10 are really, I think, just the way the information is presented, and even on the midterm, it's a pretty tough question to solve, but I'm going to go ahead and show you how to do the example here. So it says, suppose that in one stunt, 2 Cirque du Soleil performers are launched toward each other from 2 slightly offset seesaws. So here's a diagram. So we've got these seesaws, so there's basically someone here that's going to be jumping into the air, and then there's going to be somebody here jumping into the air. And so down here you'll actually see, so here's one of the performers, and then here is the second performer. So basically, they're they're both launched off these seesaws. The first performer is launched, and then 1 second later, the second performer is launched in the opposite direction. They both perform a flip and give each other a high five in the air. Each performer is in the air for 2 seconds. The height above the seesaw versus time for each performer during the stunt is approximated by the parabola as shown. Their paths are shown in the coordinate grid. So this is what we're looking at. So it says to determine a system of equations that models the performer's height during the stunt. And so I did this in vertex form because I thought that was probably the easiest to see. And so I noticed, if I look at, for the first performer, I can see that the vertex is at 1, 5. So the vertex for the first one is at 1, 5, and I'll just put a little subscript there. And then for the second performer, the vertex is at 2, 5. And that makes sense that they're a second apart because they were launched a second apart. I do need to figure out the value of A for both of these performers. So let's just go ahead and look for the first performer. I know it would be y equals A times x minus h, which would be x minus 1. Oh, that's terrible. Let me see if I can make that a little nicer. And that would be the quantity squared plus 5. And so in order to figure out the value of A, I'm actually going to use another point on the graph to do that. And so I can see, and this is probably the easiest point to use, I'm going to use 0, 0. So if I let y equal 0 and x equals 0, I'm actually going to be able to solve for A. So I get 0 is equal to, well, 0 minus 1 here is negative 1. When I square that, I get positive 1. So basically, A times 1 is just A, and then I've got plus 5. And if I subtract 5 from both sides, I get that A is equal to negative 5. So the equation for the first performer, I'm going to call that y1, is going to be negative 5 times the quantity x minus 1 squared plus 5. The second performer, notice that their graphs are parallel. So I don't have to solve for A again. I know for the second performer, the A value is also going to be negative 5. But the vertex is going to be a little bit different. It's going to be x minus 2, the quantity squared, plus 5. Okay, now that we have the two equations, we can go ahead and solve them using the calculator. So let me turn it back on, sorry. All right, so y equals, let's go ahead and clear out what's in there. And now I'm going to have negative 5 times the quantity x minus 1 squared. And then in the, oops, I have to add, don't I? Plus 5, sorry. And then in the second equation, we're going to have negative 5 times the quantity x minus 2. And if I look on my paper, like if you actually look at the diagram on your paper, you can sort of see where they're going to intersect. In fact, I don't even know that we have to do this on the calculator because we can see from the diagram that they intersect at 1.5 minutes and 4 feet in the air, or 4 meters in the air, I guess I should say. So 1.5 is your value of x and 4 is your value of y, or after 1.5, I guess that's seconds. Both are 4 meters in the air. So I'm actually not going to go ahead and do this on the calculator since you can see it right here. In the next problem, though, I will go ahead and solve that on the calculator because it's essentially the same problem, but there isn't as much information, so you kind of have to figure it out yourself. So it says, at another performance, the heights above the seesaw versus time for the performers during the stunt are approximated by the parabola shown below. Assume again that the second performer starts 1 second after the first. And so again, we're going to assume that this right here is the origin. So here is my, if I just kind of sketch my axes there, I still get the information that I need. So if halfway is at 1.5 seconds, that's actually not what it says, is it? It just says that, actually, let me clear what I wrote. Okay, so 1.5 seconds exists between when the performer goes into the air and comes down. Okay, so again, if I'm going to be using the vertex form, I've got to think about halfway between 0 and 1.5. So let me do this on my calculator. So basically, I'm cutting 1.5 in half, and I should get 0.75. Okay, so the vertex here is going to be 0.75, and the height obviously is going to be 4.5. And if the other performer starts a minute later, then I know that the vertex for that person is going to be 1.75 and 4.5. So again, I don't know the value of A. So for the first performer, I'm going to go ahead and do what I did before, where I have A times the quantity x minus 0.75 squared plus 4.5. Now what makes this a little bit more challenging is now I'm dealing with decimals, but it's really not a big deal. I know that the first performer hit the 0.00. So if I let x equal 0 and y equal 0, I get that 0 is equal to A times 0 minus 0.75, the quantity squared, plus 4.5. And so to simplify, I need to basically square a negative 0.75, since 0 minus 0.75 is just negative 0.75. And so I get 0 is equal to, so this is just the coefficient of A, so it's going to be 0.5625 times A plus 4.5. If I subtract 4.5 from both sides, I get negative 4.5 is equal to 0.5625A. And if I divide both sides by 0.5625, I should be able to get the value of A. So negative 4.5 divided by, I'm just going to do second answer since it's already up there. Oh, perfect. So A is equal to negative 8. So that actually works out kind of nicely. So I'm going to, because of the space that I have, the first performer then would be negative 8 times the quantity x minus 0.75, the quantity squared, plus 4.5. And the second performer is going to be negative 8 times the quantity x minus, it's 1 second later, so it'll be 1.75 plus 4.5. And so now I will need to use my calculator. So let me just adjust these. There's my first one. And then I've got negative 8 x minus 1.75 squared plus 4.5 again. And I'm going to go ahead and just start this on my standard window. And I can see that they intersect like right about there. And so if I hit second trace, intersect, I get that they intersect at 1.25 and 2.5. So that's 1.25 seconds. They are 2.5 meters in the air. Okay. All right, number 11. It says the area of a rectangle is given, and you're supposed to use the length to determine the length of the missing side. So, well, let's just think about it. If I knew that I had a rectangle that had an area of 12, and I knew that one of the sides was 2, I would simply divide 2 into 12 to get the length of the other side. So in this case, because I'm dealing with quadratics, I'm going to have to use long division. So I'm dividing by the 3x minus 2. And I'm dividing that into 15x squared plus 11x minus 6. So with long division, we think since this has 2 terms, I'm going to start my answer above the second term. And I'm essentially just looking at the first term and how many times, or what do I need to multiply 3x by to get 15x squared. And what I need is a 5x. So I'm going to put the 5x here, and then I'm going to multiply through. So 5x times 3x gives me 15x squared, which is what it should be. And then 5x times negative 2 gives me a negative 10x. The next step is to subtract. So what you need to remember is that you're subtracting both terms. I'm subtracting the 15x squared as well as the negative 10x, making this a positive 10x. And so when I combine, I get 22x, and then I can bring down my 6. Did I make a mistake somewhere? Oops. Huh. 11 plus 10 is actually 21. I should know that, right? Let me try that again. 21x. Now it works. All right, so I got to think, what do I need to multiply 3x by to get to 21x? Well, I need to multiply by 7. And 7 times 3x gives me 21x, and 7 times negative 2 is a negative 14. And then the next step is to subtract. Oops. And so when I subtract, I'm going to subtract the 21, but when I subtract the negative 14, I'm actually making it positive. The 21x's cancel, and negative 6 plus 14 leaves me with 8. So notice that it doesn't go in evenly. That's okay. The other side is going to have the length 5x plus 7 plus 8 over 3x minus 2. Number 12. Okay, so now we got to remember about our different log and exponential functions. You can use your calculator on this. Let's go ahead and just think about the log of x. So this is just dealing with a common log. And I'm going to actually change my window to match the graph on the paper so it'll be easier to trace. And I can see that the graph goes from negative 5 to positive 5. So it'll be a little bit easier for me to transfer, what's going on my calculator onto my paper if I have the same window settings. So the first thing I want to graph is the log of x. So I'm just going to use my log of x. I don't have to worry about a base here. And so when I graph it, I can see that my graph, and you got to remember that even though the calculator, it almost looks like a square root function, a log function does. Sorry, it's not quite as pretty as what it's supposed to be. But what you got to remember about a log function is it has a vertical asymptote, and that asymptote for the parent function, which is this, is going to occur when x equals 0. So actually, I'm going to go ahead and put that in there, x equals 0. So the domain, note that my function is never going to cross that line. So my domain must be that x is greater than 0. The range, if I look at all the y values, well, this function goes down to negative infinity and up to positive infinity. So my range is just all real numbers. When it asks about end behavior, it's basically saying as x approaches infinity or negative infinity. So as x approaches infinity, and I'm just going to use that notation, what is happening to y? Well, in this case, y is approaching infinity. And as x approaches negative infinity, y is approaching negative infinity. And that's the end behavior. The x-intercept, so that'll be easier for me to figure out on my graph, on my calculator. So the x-intercept is going to occur when y equals 0. So if I have another equation in here for y equals 0, wait till it finishes. I can go second trace, intersect, enter, enter, enter. Oh, notice how my calculator says that it's not on the first curve. That's because when my function, or when x is equal to 0, it's actually not on the graph yet. So I have to move it over a little bit. Now I can actually press enter. And it says the x-intercept is at 1. The y-intercept then is going to occur when x equals 0. And I can do that by going to second trace, value, and typing in 0. But what happens is my function can never, x can't be 0 in my function because of that asymptote. So there really is no y-intercept. So in the next equation, I'm just flipping my function. So I'm basically going to insert a negative. Everything else is going to be the same. And so my function is just going to be flipped. And that was a little better. So my domain is still greater than 0. My range is still all real numbers. This time, though, as x approaches infinity, y is approaching, sorry, this is really negative infinity. As x approaches negative infinity, y is actually approaching positive infinity. The equation of the asymptote is the same. In fact, the x-intercept is the same, and there is no y-intercept. Okay? In the next one, now we're moving over to an exponential function where we have 3 raised. I'm going to put the exponent in parentheses, just make sure I'm seeing all of it, x plus 1. And I'm going to subtract 2. And so I can see that this function starts off like this and then goes up. And so one of the things I have to remember about an exponential function is it has a horizontal asymptote. And it's always going to correspond to my value of k. So I know my horizontal asymptote is going to be at y equals -2. My domain this time, remember that with the exponential and the log functions, the domain and the range, since the functions are inverses of each other, I'm going to pretty much flip the domain and range. So the domain for a exponential function is always going to be all real numbers. That's going to be true for the next one as well. The range, this time I've dropped my function down 2 units. So instead of saying that y is going to be greater than 0 like it was with these parent functions, it's going to be that y is greater than -2. In terms of my end behavior, as x approaches infinity, y approaches infinity. But as x approaches -infinity, y is actually just approaching -2. As we go back this way, y just gets closer and closer to -2. The equation of the asymptote, oops, I put that in the wrong spot. The asymptote is y equals -2. And so the x-intercept, the x-intercept is right here. Again, if I just find the intersection with the y-axis, I've already put the 0 in there. If I hit second trace intersect, enter, 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 I get that the x-intercept is -0.369. And then to find my y-intercept, again, I'm just going to let x equal 0. And I can do that right here on my graph, going to value, plug in 0, and I get the y-intercept is at 1. And then lastly, we've got y equals, notice that there's not a parentheses around the -2. So it's going to look like this. The domain, again, is all real numbers. The range this time, notice since the graph is going down, y is going to be less than the asymptote, which is at 0. End behavior, as x approaches infinity, y is going down. So as x goes up, y goes down. And as x decreases, as it goes to -infinity, y approaches 0. The equation of the asymptote is just going to be y equals 0. There isn't going to be an x-intercept. And the y-intercept I can find just by going second trace and letting x equal 0. And I get that the y-intercept is -1. The other way that you can find the x-intercept, letting y equal 0, is using second trace. Notice you also have a 0 command on your calculator. You can choose that as another way to find the x-intercepts on your graph if you want. Okay, we're almost done. We've got a few more problems to go, and then we're done. So for 13 and 14, it says to consider the graphs of the given function and then determine which of the statements are true for each. So notice what the statements we have are there is a vertical asymptote at x equals 2. Well, if I'm dealing with a vertical asymptote, if you think about our properties, the only way there's going to be a vertical asymptote is if I have a logarithm. So, oops. So this is only going to be true for a log function. And the y-intercept is at 62. We'll have to test that. And then no x-intercept for the graph. So let's just graph these. So if I graph number 13, that's going to be the easiest way. We have 15 times the quantity 0.5 to the x minus 2, and then plus 2. I'm probably going to have to change my, so let's try zoom 6 and see if we see anything. Okay. So it says there's a vertical asymptote. I know that statement 1 is not going to be true. So I know that A is not correct. So if A is not correct, then obviously D is not going to be correct. So I'm looking at between 2 and 3. It says the y-intercept is at 62. So let's see what happens when I let x equal 0. I get a y-intercept of 62. So statement 2 is correct. And then it says statement 3, there is no x-intercept on the graph. So because my function is above 2, I know that it is true. There is not going to be a x-intercept on the graph because the asymptote lifts it up. So let me just double check this because this is kind of weird because 2 is correct and so is 3. I think I forgot to adjust this problem. Because 2 of these things are true. So in terms of the choices that you have available, it actually would be B and C. I think there's a mistake here. B and C are both correct. So I apologize for that if that was confusing to you. Let's see, in number 14, now we're looking at a log function. We do have to be careful because we're dealing with a base 2. And so when I'm graphing, I have to remember when I graph, I'm going to type the log of x minus 2 divided by the log of 2. Now, if you have one of the newer calculators, if you go to, I believe it's, this calculator doesn't do it, but if you go to math, and I believe number, I can't remember. Or maybe it's just under the math button. There's something about log with a base. The calculator that I'm using doesn't have it, so I actually have to use the change of base formula. So I'm going to have to type in the log of x minus 2 divided by the log of 2, and then minus 1, and then graph it. And so in this case, there is a vertical asymptote, so 1 is true. The y-intercept is 62, that is not true, so it can't be 2. And then it says there is no x-intercept, so 3 is false as well. So the only thing that is going to be true is 1, statement 1. Okay, these last few problems, actually, I'm going to save this as a, well, no, I'll go ahead and do a third. All right, so the last few problems deal with probability. And we didn't really get to probability this semester, but all of the questions are really things that you did in Algebra 1. So I'm just going to review them because it's fair game. You've learned them before. Even though we didn't really spend a lot of time going over them, you're expected to know them. This is on the HSA that you guys have all passed. So it is expected that you guys should probably be able to answer these questions. So in number 15, it says, suppose you flip this coin. So this is a quarter. Suppose you flip this coin 4 times and flip heads each of those times. So you're given several answer choices to select to answer the questions A and B. So it says several answer choices are provided below. Fill in your choice for each question. You may use the same answer or choice for both questions. So the first question says, given that the first 4 flips were heads, the probability that the 5th flip is heads is, well, if you think about it, the coin has no memory. I could flip 10 heads in a row. The chances of me hitting another head is still 50%. Now, part B is asking a different question. It's asking, what is the probability of having 5 heads flipped in a row? So this is a little bit different. I can flip 4 heads. The chance of getting another head is still 0.5. But if I'm really trying to figure out the probability of having a strand or a string of 5 heads in a row, I've got to think about the probability of heads and heads and heads and heads. How many is that? 1, 2, 3, 4, and heads. And as long as my outcomes are all independent, meaning that they don't affect one another, then this is going to be the same thing as the probability of heads times 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 the probability of heads. And so since the probability of tossing a head is 0.5, basically multiplying 0.5 times itself 5 times. Or another way of writing that would be 0.5 raised to the 5th power. And if I do that on my calculator, 0.5 to the 5th power is simply 0.03125, and that is answer choice 3. So 0.03125, and it's not clear if you're supposed to do the Roman numerals. I guess this would be Roman numeral 1, and this would be Roman numeral 3. All right. Number 16, it says a class was surveyed and 32% of the students had a tablet, 96% of students had a cell phone, 22% of students had a tablet and a cell phone. What is the probability that a randomly selected student from that class has a tablet or a cell phone? So this is where you can look at your formula sheet, because we've got some probability formulas for you on the second page. And so what I want to do is look for the probability of A or B. The probability of event A or B is simply the probability of A plus the probability of B minus the probability of A and B, or the probability of both. So if we go back, I'll write this down. So the probability of A and B is equal to the probability, oops, I wrote this wrong. It should say or. I've been doing this, it's been a long day. So the probability of A or B is simply the probability of A plus the probability of B minus the probability of A and B. All of this information is given to you. So if we're saying the probability of a tablet, I'm going to call that probability. I'm going to say T is for tablet, and I'm trying to find the probability of tablet or cell phone, so I'll call cell phone C. So then I want to find the probability of a tablet plus the probability of a cell phone minus the probability of both. And all of that information is given to you in the problem. So the probability of a tablet is 32%. You do need to remember that with probability, the percents, you want to change them to a decimal. So it's going to be 32% plus we have the 96% of students that have a cell phone, and then we want to subtract away the overlap. And so if I do this on my calculator, 0.32 plus 0.96 minus 0.22 is 1.06, and that's impossible. Huh. Let me double check this. Okay, well, this is impossible. You can't have 106%, so we actually made an error in this problem somewhere. So just focus on the process for solving, or the process for finding this probability. The sum should be less than 100%. There's no way that you can have a more than 100% chance of something happening. But to find the probability of one thing or the other, you add the two individual probabilities and then subtract the overlap. Okay. In number 17, it says, the students at the school basketball game were asked what their favorite football team was. The information that was gathered is in the table below. According to the distribution, it says to estimate the probability of picking a student who would have, picking a student would have, that is a Steelers fan or a Redskins fan. Okay. I'm sorry, we must not have really proofread these very well. Okay, so we're looking for them being either a Steelers or a Redskins. Steelers or Redskins. So I know that I have a total of, so we're looking for probability of Steelers or Redskins. When you have a table, it's actually much easier, because I know I essentially have, let's see, 62 that are, well, let me actually just write this out. I have 32 fans that are Steelers fans, and I have 30 that are Redskins fans. In order for me to find the probability, though, I have to divide by the total. And so we have to add all of these values up to get the total. So 30 plus 15 plus 32 plus 24 plus 28. So all of the looking at 129. So when I simplify this, we have 32 plus 30, and then when I divide that by 129, we get 0.4806 or 481. And if you want, you can leave it as a fraction. It would just be 62 over 129. It doesn't matter. You can leave it as a fraction or a decimal. I think sometimes the decimal makes a little bit more sense when we're thinking percentages, because that basically means 48.1% of the fans either root for the Steelers or the Redskins. All right, last problem. This is a conditional situation where you're given a two-way table. It says the table shows the results of a survey of 84 students about genetic traits. So we know that there are 84 students in this table total. All right, so it says if a student is selected at random, what is the probability that a student is a sophomore given that the student is left-handed? So the way we write this in terms of probability is using conditional probability. The probability that the student is a sophomore given it's a vertical line that the student is left-handed. And basically all that means is that we are narrowing down the group. So we're not actually talking about all 84 people. We are just talking about the group of students that are left-handed. That's what this given information tells us. That's what this condition says. So I'm just looking at the left-handed students. So I'm going to find out how many students are left-handed. And so I'm told that there are 33 students in this survey that were actually left-handed. If I want to know the probability that they were a sophomore, then I'm going to take this 10 and divide it by the 33. So it's 10 out of 33. And 10 out of 33 is about 30.3%. Okay, and that's it. That's as hard as the probability gets. So it really is just what you did in Algebra 1. It's the same thing. And so we do expect after the review and going over these problems that they're fair game for the midterm, even though we really didn't get to covering any of the new content. The questions that are on the midterm are no harder than they were in Algebra 1. So we do expect you to do those problems and you know, get them correct, because you should. Good luck, everybody. I hope this was helpful.